Hi, welcome to this series of videos about how to read news articles about science presented by the Harvard Undergraduate Science Olympiad. In this particular video, we're going to focus on how to read data and graphs. And when it comes to reading data and graphs, there are potential ways the article or author may present the data such to skew the reader's attention or opinion. So there are going to be 4 major ways that this can happen and potential ways to spot it and how we approach reading data and graphs in general. Truncated graphs. So what exactly are truncated graphs? If we take a look at graph 1 and graph 2, we can see pretty stark contrast between the bars itself. But looking closer, we can actually see that the values for each individual bar are the same. What's different is that on graph 2, the baseline starts at 70, whereas on graph 1, the baseline starts at 0. So noting that, we can see that graph 2 is actually a truncated graph because its baseline is not located at 0, instead it's located at 70. Doing so, the author may do this to show there is a huge difference between bar 1 and bar 2 in graph 2. But if we look at the data from a standpoint where the baseline is 0, it is actually not that big of a contrast. There are many reasons as to why an author may do this, or how and why a data may be presented like this. And that's because they may be wanting to show a difference between the bars and show that this is a very large difference, when in reality, it is only a slim difference, relatively. So this is a potential way data may be presented. It is important to spot that. And a solution to spotting this kind of bias or skew viewpoint in the data is to note where the baseline starts. If the base starts at 0, then that would not be a truncated graph. If the baseline starts at 70 or a number other than 0, it would be called a truncated graph, and that would be something to note moving forward in the article. On this next slide, we're going to talk about manipulating the y-axis. Taking a look at graph 3 and 4, again, we can see that from afar, they look quite different, but then looking closer, each individual data point is actually the same. Now, this difference and why this happens is different from the previous slide. But the main reason we can see here is that the y coordinates, the y-axis, is changing in that the scale is different. So for graph 3, we're going by tens, 0, 10, 20, 30, 40, 50. But then we look at graph 4, it goes 0, 5, 10, 15, 20, 25. So knowing that the difference between each individual data point in graph 3 is minimalized, but then in graph 4, it is exaggerated because of the scale on the y-axis. So it is important to note that using a scale on the y-axis can skew how the data is portrayed. So that is important to keep in mind. However, sometimes it is useful to have a smaller scale, such as graph 4, and sometimes it is helpful to have a larger scale on graph 3. And this depends on how far spaced out each data point is. And it is just important to note, to keep in the back of your head, that this is a potential bias. There is no right or wrong answer in this case, but it is important to note that maybe the difference between each individual data point is not as large as the graph may portray it to be. On this next slide, we can see that graph 5 and graph 6 are actually entirely different graphs, whereas in slide 2 and 3, when we went over truncated graphs and manipulating the y-axis, those graphs were actually pretty much the same because the data points itself were the same. However, in selected data points, the author or scientist may choose to only include certain data that will help their case or their argument. So looking at graph 5, it actually goes by months on the x-axis, whereas on graph 6, we're going by years. So looking at these two, also depending on the situation, it is important to note that maybe only including January through June may not be representative of the entire data, because that may beg the question of what happens to the rest of the years. So maybe potentially in this situation then, 2001 to 2005 will show a better clear distinction in the data and progressiveness throughout the years. And lastly, we are going to be going over types of graphs and different types of data that are associated with it. In this example, we have a bar graph on the left and pie chart on the right. And in this particular situation, pie charts can be misleading because pie charts are originally used to compare parts of a whole, not the difference between groups. Thus, a different type of graph should be used to compare these three groups. And a bar graph, is actually going to be more accurate in this situation because it's better for showing the difference between groups and overall gives a better visualization of the data. So, this wraps up our segment in data and graphs and potential ways that bias or ways to skew the result of the article have been presented. It is important to note that this is an important thing to keep in mind. These 4 particular points, because this will help you determine whether something in an article can be reliable or not, and if the data is actually presented in a way that is not skewed or biased in someone else's favor. So thank you for watching this video, and I'll see you in the next one.